Hello. In this presentation, we will be discussing about our project predicting house sales price. We are a team of three people: Ashok Kumar, Savan Salian, and myself, Gautam Mallikarjuna. In this presentation, these are the main points that we will be covering. We'll start with project objectives, and then we'll discuss about the data preparation and reduction part, and then we'll explain about data modeling techniques, and then actual model building, and then the assessment how we selected the model. This is the summary of our project. The main intention of the project is to predict the house sales given various attributes in the Washington area. We have a dataset which contains the house sales prices including its various attributes in the time between May 2014 to May 2015. Basically, it's very important to predict the house sales accurately for both the home sellers and buyers. So sellers can use this model to understand the various factors affecting the selling price and can make the improvements to the home to get a better price. And then also the buyers can use this model to find and understand the house price that they may have to incur while buying a house. The main objective of the project is to understand and determine the influence of various factors on the sales of a house in a Washington area. Build a model to predict the house sales based on the house characteristics such as the living room location, number of bathrooms and floors, and the area of the house, and there are many other factors to which determine the final price of the house. The data preparation process, these are the various processes that we followed. The data we obtained has actually taken from the Kaggle website, and in this data we had total of 21,000 house sales prices listed in a CSV file, and the target variable for our analysis is the house sales price. And there are various predicting variables such as the date of purchase, bedrooms, bathrooms, and square foot of living area, and then square feet of lot, number of floors, waterfront view, the house condition, the grade, and the year built and year renovated, so that we can calculate the age of the house and then the number of years since it is renovated, and also the zip code, latitude, longitude, with which we can find out the area details like the city name and so on. And we actually have extracted the city information based on the zip code using the R functions. Data preparation part, initially we have identified that there are many categorical variables and then the continuous variables in our data. The categorical variables like waterfront is a variable which is binary, whether the waterfront is present or not, and the condition represents the quality of the house construction. And the city variable, which is a categorical variable which is used to identify the location of the house. The other location related variables such as the latitude, longitude, and zip codes are redundant variables that we don't need to use since we already have a city variable in our analysis. And we prefer to use all the levels of the city variables to consider individually how each city is affecting the sale price instead of grouping them and reducing the number of levels. And then the next steps, we observed that there are no missing values, so we don't have to do any missing value imputation in our data. And there were many outliers and influencing outliers in the data which will have unusually large values, like we can see in the box plot here. In the many variables like square foot living and the area sizes, and there are many other variables like there are bedroom values which are greater than 9, which are unusually large, which might really influence our analysis, which are removed, like 13 records have been removed from our data. And also the house records with a sale price greater than 4 million are removed, assuming that they might have additional features which are not captured in the dataset. Further, we performed a data transformation since we had a large number of outliers and the highly skewed data. And as we see here, the original variables are highly skewed, like age of the house and renovation, and all these variables. So we had to perform log transformation to make the skewness the variable normally distributed. And then we initially thought of doing some time series analysis, since we had a time variable so that we can predict or forecast the house sales price in future. But the problem was, like, we had only 1 year of the data, so say, time series analysis with 1 year of data will not be so beneficial. So it then we decided not to go with time series and then finding any seasonal variations. Then further we had many categorical variables. Here we can see most of the categorical variables with many levels, of all the levels having seems to have influence on our target variables. So we had to retain all the levels without combining them to create lesser number of levels. And then coming to numerical variables, we actually performed PCA and factor analysis to find out the most important variable that will influence our target variable. And then we can see we have after factor analysis and PCA, we have four very useful variables that we retain for our analysis. After doing the data reduction, we finally have these many variables, like square foot basement, and then city, square foot living, bathrooms, view and condition, waterfront and floors, and target variables is the sales price. The modeling techniques, we had to assess many assumption of our models, like the linearity of all the independent variables with our target variable. For all numerical variables, we can see in this scatter plot that all the variables are reasonably linearly related to the target variable. And then we decided to go with multiple linear regression and then the regression tree as two of the two models. And first is the multiple linear regression. Then for that we have to analyze various regression assumptions, like linearity, relationship with a dependent variable, and normality of residuals and homoscedasticity, a constant variance. Like we can see that most of the assumptions are valid, even though we have slight variation that should probably be okay with our analysis. And then also we had to check multicollinearity problems. So we analyzed various variance influence factor, where which is less than 5 are only considered to take out the effect of multicollinearity.
Hello, my name is Savan and I'll be covering the model building part of this. So initially we split our data into training and validation data sets. So 70% of the data was split into training and the remaining 30% was split into testing. And we use root mean square error as the metric which will use using which we will be assessing our model. We compared the standard deviations of the target variables in the training and the testing datasets, and we found out that they are more or less the same. In the training dataset, the values of standard deviations were 0.7688, and in the testing dataset, it was 0.7697, which confirmed us that the data has been split properly in both the training and the validation datasets. And multiple regression was one of the models that we had used to build our model. When we ran the multiple regression, we found out that three variables are very important. Like the three variables are square feet living, city, and the number of floors in the house. So if we see that the p-value is less than 0.05 for these three variables, that means only these three variables are significant. That is the city, the square feet living, and the number of floors. So if we see the number of floors, we see that as the number of floors increases, the cost of the house goes up. For example, uh, a house which has floors 2.5, the parameter estimate is 249,164, which means for one unit increase in floors, the price of the house goes up by so many units, 249,164 units. And there are some surprising results, like for the number of floors is equal to 3, the value is less, and again for 3.5 the value increases. Also, we see that R square value is 0.6474, which means almost 64% of the variability in the target variable is explained by the independent variables. Now, coming to the regression tree model, the regression tree identified the variable square foot living and the city as the most important variables. So if you see the regression tree, we see that the first split is happening based on the square foot living, and if that value is less than point, if it is less than 2330 square feet, it will check if it is less than 1422 square feet, and if it is less than 1422 square feet, then it will check if the city is urban. If the city is urban, then the price will be a factor of 5.298. If it is not urban, then it is 5.507. So this is how we can interpret this decision tree, which told us that the variables square foot living and city are the most important variables. And this actually is the same as what we got in the multiple regression model as well. So coming to the assessment of models, we use root mean square error as the metric with which to check the accuracy of both the models. So with multiple regression, we got the training RM root mean square error as 0.11, and in the validation data set we got the root mean square error as 0.26, and with regression tree we get it slightly higher for the training, but for validation we get it to be lesser than the multiple regression model. Since the value of root mean square error is lesser for the regression tree in the validation data set, we can say that regression tree is the better model as compared to multiple regression. Also, regression tree is a simple and easy model to be built, and it's not as complicated as multiple regression, and it doesn't have any assumptions. One more advantage of decision tree is that we can get the values at every split. How we can find out how the split in the independent variables affect the target variable. So coming to the strengths of multiple regression, here we can find out like how individual variables affect the final outcome, how it affects the target variable. We can find out like if we can find both the positive and the negative effects of every variable. For example, we can find out which variable is affecting the target variable positively and which variable is affecting the target variable negatively. Also, our data set had a mediocre number of rows. It had 21,000 rows, and using multiple regression we got very accurate results. Coming to the weakness of the multiple regression model, we see that it is sensitive to outliers. This is one of the drawbacks. And also it cannot deduce causation. And one more weakness is that there are a lot of assumptions which needs to be validated before doing a multiple regression, and also in practicality it is not very feasible. For example, there cannot always be linearity between the independent variables and the target variable, so it is one of the drawbacks. Going to the advantages or the strengths of the regression tree model, we see that it can handle non-linear relationships between the variables. Also, it can handle both categorical and continuous variables as well. And these are the two main advantages of the regression tree model. Also, we can find out how the splits in independent variables affect the target variable. We can find out at every split what is the effect, which we cannot do in the case of multiple regression. One of the disadvantages of regression tree is that it is very sensitive to small changes that might occur in the data. For example, it might not be able to calculate the nuances in the data which affect the target variable. Also, as the number of variables increase, the regression tree becomes more and more complex. Coming to the original vision versus the final product, as in like what we had decided to do initially and what we ended up with finally. Initially, we had decided to do time series analysis using our data, but since our data was only for 1 year, we thought it is not a good thing to do it. It is not considered because the data is only for 1 year. We also thought we'll connect the weather data to analyze the impact on the house sales price. But since the data was restricted to only the Kings County in Washington, this was not considered as it would have been the same weather for all the areas. Also, we thought we'll incorporate the zip code using which we could do further analysis like population density, per capita income, number of industries, and how these affect the target variable. But given the timeline and scope of the project, this was not considered to be feasible. Coming to the lessons learned, we listed down a few of the points that we thought we actually learned from this project. First of all, we learned that the scope must be carefully decided at the beginning of the project and not during or in the middle of the project. Also, a lot of time must be spent on initially estimating the time requirement for every phase of the project. This must be done before starting the project itself. Also, business understanding of the project is very important, and analyzing the data in the beginning is very important, and the models must be chosen based on these. We also learned how to coordinate with the different team members, and we also learned how to manage our time effectively because we had to meet certain deadlines and submit our project within those deadlines. We also learned how to use RPython and all the different statistical tools and techniques. We used R and Python mostly in this project. Coming to the approach to problem solving. We learned about the various data collection issues that crop up during the project, and we cleaned the data, and we cleaned the data first, and then we filtered out unnecessary variables. Also, we analyzed descriptive plots before moving ahead with the data transformation. We also used principal component analysis and factor analysis to reduce the number of variables. And using R and Python, we were able to do descriptive statistics as well as data cleaning and the model building. Also, we had reduced the number of levels of the categorical variables using binning. On to the conclusion, the final model that we selected is the regression tree because, as I said earlier, the root mean square error is lesser for the regression tree as compared to the multiple regression model. And it is a simple model. I mean, the regression tree is simple to analyze, easy to analyze. Even a common man looking at it can easily interpret it. And it can handle nonlinear relationships as well. It can also take care of both categorical and numerical variables, and this is one of the major advantages. Going forward, we can improve the performance of this model by building advanced modeling techniques like bagging and boosting. Also, we could have incorporated more features like the cost of the material used and detailed explanation on the house characteristics, which could have helped us more in accurately identifying the house sales price. Thank you.